un altro microfono. Regia, mi sentite? Ok. Regia, sono i spaghetti. Regia, sono i spaghetti e sto testando un microfono. Regia, sono i spaghetti e sto testando un microfono. Regia, sono i spaghetti e sto testando un altro microfono. Un altro microfono. Un altro microfono. Regia, sono... Yeah, I'm just testing this microphone because I didn't test it. I didn't know you were so many. So actually, I thought to use that one.
Here and singing session. Please welcome the Spotify barbershop.
Oh, okay. Okay, we have the... Yeah. Yeah, okay.
Yeah.
So we are here in, with the Spotify guys. Guys and girls, actually. Okay, so this is a question and answer session. I guess they already have something ready to start the discussion. And just if you want to ask anything about Spotify, also the food, I think. You can raise your hand, and I will run to you, and you can have your question.
Yeah. So, hi everybody. Thanks for being here. This is the impromptu change of slots. We had started with something like the monitoring subject, and then we switched topics when you had so many good questions. My name is John, and I have been working for Spotify for basically since the beginning. And these are the newbies behind me. And we have a wide range of backend services, and most of them are written in Python. And we usually do a bit more than people suspect. So what's this streaming music thing? It's like one service or two, and it's a bit more. So as I said, I've been starting Spotify since the beginning, and then we were building the basic infrastructure parts. And now I'm in a team called the platform team, where we have many different APIs that people can use to build their own Spotify things, like a web API, an inside application apps API. You can use JavaScript. There's a lib Spotify C library. You can build your own client, the web APIs I've mentioned, and there's other HTML widgets you can put on a website. So we will start actually by just mentioning who we are and what we do, so you can get a range of what's happening at Spotify. So please continue.
Hey, my name is Jyrki. For those who didn't see my talk yesterday, I actually work in the content team, so I'm in a team that takes care of getting the music and metadata from labels and actually processing it through our systems and finally releasing all the search indexes and music for actual playing. So kind of core part of our stuff, like getting stuff from labels and building the pipeline for smashing all the terabytes of data to the world.
Hey, I'm Martin. I've been with Spotify for 6 months now. I'm in a team called Infrastructure Automation. Just quick show of hands, how many here work with system administration? Fair amount of you, okay. And I'm guessing in your work you have probably been automating whatever you've been doing, and at some point you've been sitting having the perfect idea in your head for how to automate stuff and how to build a framework, but then your boss is putting you to other work, right? Well, my job is basically to go to on the other side of that line. Our system administrators are few and our servers are many, so basically my job is to build tools for them to make their job easier, and Python is the tool we are using for that.
Hi, my name is Matthias, and I've been with Spotify for 9 months now. I'm working as a backend developer with the services that are closer to the music player, apart from other parts of the backend.
Hi, my name is Delphine. I'm not a developer. I'm part of the HR team working with recruitment. I've been at Spotify since November last year. So if you have any non-technical question, I'll be happy to answer.
Hi guys, I'm Alex. I work in the payment team. So we handle all the subscriptions and the payments that our subscribers are when they're subscribing to the service and when they are when they're upgrading or something like that. We do interfaces with banks, with our payment providers. We do reconciliations and settlements and all that stuff. So people tend to think that that part of our business is sort of not important. The team is small and who cares about payments and stuff like that. But if we would turn off our service, nobody would be able to use Spotify. So that makes us pretty much very important in the So yeah, we handle also subscriptions, monthly, recurring, and yeah, it's pretty interesting to handle all that money.
Hi, I'm Jonas, and I'm the one singing all the songs in Spotify.
Yeah. Okay, so that was the brief introduction. Who here came to want to hear about the monitoring subject? That was actually the sort of the printed text in the... Okay, so 1, 2, 3, 4. Okay, so maybe we can, before you shoot at us with the questions, we can a bit address that part, even though we don't have like a full hour topic. So Jyrki's talk, he mentioned that we're using, or in the questions, that we're using Moonins for graphing everything, and that's usually how we sort of detect all the bad things or the good things about all our services. So the Moonin is a very like simple framework. Just apt-get install Moon, and it starts like printing graphs on a web page somewhere. You can't even find it in the beginning. And then we have since we have so many servers and then sending all these data around, we have built special services to make sure we don't overload our own servers with like statistical information, like monitoring. But that's basically it. The most important part is to make sure to monitor every value that you can think of, even though it's like super, like this has no significance to the system. So when you have an error, when you're approaching the sort of roof of what the system can handle, you don't know where your limit will be unless you have a measurement that can sort of show something and go up and down. And then after a while, you still don't know the limit, but after a while it doesn't go much higher. Then you'll see like, oh, this is maybe how many files or whatever you can open, and then this is a Linux kernel limit, and you raise that one and you go to the next step. So it's the monitoring situation is basically nothing more than that. Then we have a different area of monitoring to see when the system is down and making sure that operations, not Martin but his colleagues, to notify them and send them SMS and wake them up in the middle of the night so they can fix the problems. And that's just basically taking those monitoring levels that we have figured out what they mean and setting limits, and just if we approach that limit for a few minutes, then that's above the threshold, send emails, and then if we were even higher, start sending SMS, and I don't know, more ways to making sure people just wake up and fix it. So that's another thing. Now we're sort of worldwide, so we have people sleeping all the time, which also means we have people awake all the time, and they can do stuff. So that's a bit about the monitoring, I guess. Should we start with the questions already? Yeah. So who here wants to fire? Yeah, and we can just dive into that. Yes. Oh, here we go.
Hi. It's not very technical question, but I'm interested. When are you going to go into Poland?
Oh, we were actually waiting for those questions yesterday. No one is asking.
Yeah, I was asking this last year, and I will ask every single year you are here.
Until we come to Poland, yeah.
I'm very patient.
Yeah. I don't know, actually, about Poland. So, as you know, we're in many European countries, except this one, and Poland, and a few others. And we started out in Sweden, and we just became the best of friends with all the labels in Sweden. And they told their bosses, like the European managers, like, oh, these guys from Sweden, you should totally do a deal with them. So we got their permission to sort of take over the rest of Europe. And then they told their bosses, like, oh, you should come to the US. And then that has been sort of our focus. And we managed that last year. So now we can, like, now we can take all the other countries. So I think there's going to be, in a few months, not this year maybe, but like the rest of Europe is slowly, we want to have it all, of course. That's the purpose. We want to take over the world. And then we're going to go Asia. So we actually had this, first we take Manhattan, then we take Berlin, and we've already done that part. So what's next? Like Krakow, let's go there.
They're waiting to come and take my money.
Yeah, yes.
All this, we understand that people want to have Spotify everywhere, and that's really our goal, and we really want to push it and enable Spotify to be used everywhere. And it's technically possible, and we have infrastructure to support that, but it's usually just legal issues with licensing and labels, and they are sort of like a big dinosaurs that they can't really move that fast like we can. We're very flexible, young company, startup, and all that. So we have to sort of push them around a little bit, and that's the part. When are we going to go to Poland? Well, when we push the little or a big dinosaur a little bit into Poland. So that's basically the issue there.
And this is a sort of good representation of the back-end technical people. But as you suspect, we have like a few legal ninjas in our team as well. They're not here. They're busy talking to Poland, I guess. Yeah.
I always say that it's Spotify is the most important part of Spotify is the legal team, the really, really good lawyers who can talk to them, the labels really, really well. So.
So I've got a question of how you're dealing with the fact that you are storing personal information, right, I suppose? And the fact that different European countries enforce different laws regarding that personal information. Like, for example, Spanish law is one thing, French and so on. And how are you dealing that in terms of infrastructure, or are you storing everything in a specific place?
Yeah, so we're taking the least common denominator of sort of what we can store. But we don't actually store that much. We have usually the most contagious issue for people is that it's a requirement to have a Facebook account to start using the service. And that is like way more information than anything else that we store. So it's just like email, person, and if people are paying, we want their sort of credentials that we can charge them money, but that's about it. Then after you have played your music, we get the profile of, you're a totally rock and roll guy, which means that ads people can target, we're going to give this ad to people who listen to rock music or pop music or classical music. And that's done just by looking at the insane amount of logs that comes from everybody playing music, and then doing a big Hadoop job is usually the way we do those analytics, and figuring out like a profile of the user. But it's nothing more than I just said. So if you have more additional, please.
Yeah, I'm kind of interested in the whole profile and stuff.
Oh.
So for example, I did a bit of profiling, but with mice and DNA. So.
Yeah.
But it's kind of the same thing. The profiling you do, is it a specific point of time? Let's say this guy likes rock and roll, or is it a profiling that you do over time? Let's assume I start listening to AC/DC, and for some bizarre reason, I start switching to Lady Gaga.
Yeah.
That's a bizarre thing.
It can happen, right? So let's say that you cluster my profile in a rock and roll kind of cluster.
Yeah.
But I start shifting away from the rock and roll.
It's nothing advanced at all. So it's it's basically one table, like a user table with a few columns about your information, and then we also have a Cassandra cluster with you can store key value blobs of sort of structured data, and the table just includes the the email, the ID, and sort of the credentials, so you can log in unless you have a Facebook account, because then there's nothing there. And then the Cassandra blob, that's basically it. That type of what you're listening to, and it's calculated maybe like once every third or fourth month, and it's not that it's not done often at all. And
so if you listen to Lady Gaga for a month and then go back to AC/DC as you should, probably, then you're fine.
Exactly, you wouldn't notice.
Yeah.
Well, we do it after the fact, and it's not. I don't think we do it very often.
If you on the technical side of view, we actually do like how we do this is like a vector representation of the stuff you listen, and then we calculate like the Euclidean distance between. So we build like a vector representation of this song is played this much, and then we calculate the Euclidean distance between songs and think that, oh, you might like this one here, but we have to chop like a part of the top off, because otherwise everything would be related to Lady Gaga. And so we fine-tune that every now and then to to get more better.
Actually, I might be wrong when I said we don't do it real time, because now last month we introduced a radio service where you can start listening to a station. You sort of give it a seed value, and then you can give thumbs up, thumbs down, and it will adapt to. That's sort of like the Pandora radio stations, if you have used those. And those are more real time, but still not that cool. We want them to be even better.
Yeah, I just want to add one thing about personal information. For example, I work in a payment team, so we handle quite a lot of that in terms of credit cards and stuff, but we don't store any information like that. We just let it go through our system and towards our payment provider. They store payment information for us. And then we get like a virtual number, which we use then next for recurring transactions. So our service is very compliant in terms of not storing that sensitive information.
So who here wants to know about the technical background of our services? Yay, 1, 2, 3, 4, yeah. Yeah. We actually tried to yeah. So he was he would like to see sort of a view of the interface, and I guess it's a very valid question, since maybe not all of you have even tried Spotify. We tried to hook up the screen before, and it didn't work. But basically, it's just like any other normal music player where you play your own music that you have on your computer. The only difference is that they are not files on your computer, and when you search for your stuff, you find everybody else's music as well. It's like the 16 million tracks. This is like a normal number for a country to have, and that includes the Lady Gaga and the other Lady Gagas as well that you haven't even heard about. So most people have said in the beginning that the desktop client looked like iTunes, but then the mobile client, and we have also, as I mentioned before, I'm in the platform team, and we have a C library called libSpotify. Companies are taking that library and building in Spotify inside their product. So like there's a sort of speaker company called Sonos, and they're building in Spotify into their speakers directly. And that means like it's even a more different interaction than the normal client. So we aim to look like anything, as long as you can play music and it's sort of coming from us. That's sort of a goal, to be the operating system of music everywhere. Got it.
It appears to me that like every week I see somebody using or recommending a service that is much smaller than yours, but still exists. And I wonder how many commercial legal entities like as big as you or bigger, like in the case of Amazon? And how many smaller players are in the market in the order of magnitude? Because I can even...
Yeah, if you look at the US market, that's where sort of everybody are, except Deezer, the French service. So we are, I think, pretty much the biggest after Apple. And then there's like a whole range, like probably 30, 40 tinier version that sort of looks like Spotify. It sort of offers the same thing, but with a slightly different approach. So I would say there's like a handful or maybe two of like good companies that have been around for a while, maybe not as long as we have, but and so there's a pretty good competition. But it's like I said, it differs from where you look. Like in any country, it's a totally different situation. And in Sweden, since we started there, it has become very like the norm. Like you don't know what Spotify is, they will find you strange. It's already ingrained in the culture, which we find scary but lovely at the same time.
Hi. I'm just curious about your what technology do you use to store all your files? I mean, do you use a file object storage or a classical storage system? Did you develop your own? Do you use external services?
For all the data we get from labels, like which is by far in terms of file storage, the biggest blob we have is then that is stored to a commercial system called Isilon. So it's like a blazing fast disk system spitting out 8 gigabits per second if we need. And for music that you actually play, we store it in what we call is our production storage, which is like a huge storage in the cloud. We use some CDN for that one.
Yeah. So
and then when you play music, we copy the stuff from the CDN to the actual site, and we have terabytes of disk there, and that's like on-disk cache in that case. And then most of the plays eventually just hit the on-disk cache, and we never invalidate anything from there because it really doesn't cost us to store stuff on hard drives.
But the actual secret is we store stuff on your computer. So if you play a song more than once, the second time you play it, you have already downloaded the audio. And then we also have a peer-to-peer system in the desktop client. So when you are like double-clicking a track, you want to hear it as fast as possible. At that point in time, I think even like the sort of first mouse down event, you're sending out request to the backend system like, hey, please give me the beginning of this song. And you're also saying, hey, who else has this track? Then it's like almost, you can read about this, there's a good white paper on our system, but it's almost like the BitTorrent concept, that there's a tracker that you ask, like, who here has this file? Oh, this ID just listened to this before, so you can try to check with that guy. So you begin by doing this thing, fan out question in the beginning, and then you just try to get the result back as quickly as possible. And usually the server can give you the first, it's the block of 64K, like the first track. And that means a few seconds or less. But that's in computer time, that's an infinite amount of time. So then other clients might respond, and usually in a country with good internet, like in Sweden, and no wireless thing, you will probably get the first part from the server, 64K, and the rest from the peer-to-peer net. And then, so it's in your cache, and the thing that's in your cache might go out to others. So if you look at this distribution of how much come from, it's 50% are played from users' cache, and about 30% come from the peer-to-peer net, and then 20% from our service. And it's like a chained cache back to S3 eventually. But that's a, whoa, That's sort of the easiest part of the system. Just storing file. Yeah, we have a web server. We put them there.
I may just add a little thing to that. The other little secret is actually human behavior. With all this music in our catalog, we can also sort of see what people are actually listening to. And one of the more interesting things to see is that out of our millions of tracks, half of them have never been read from disk. Half the music we have never been listened to by anyone. So whenever someone tells you, oh, I have a really unique taste in music, not really.
Yeah.
Everyone listens to the same.
And half of the tracks that people do play have only been played once. So it's like really, really, most people only listen to the top 1,000 tracks at any point in time. So if you want to build a music service and you want to don't have millions of tracks, just pick the top 1,000 and no one will notice, barely.
As you said, you have the peer-to-peer communication using the storage of the disk of the user. How do you do with the cache and mechanism to remove that, or you are just like a virus and use all the hard drive of the user?
No, it's least recently used cache with a fixed size, but that fixed size is slightly dynamic, so it goes like up to the first limit of either I think it's few gigabytes even, or 5% of the free space left. So usually you hit the free space limit first, but that usually means even if you don't have any room to store, that still usually means a few hundred megabytes, and that's enough just to be able to store the 10 most recent tracks is usually helpful for saving bandwidth. So and it's purged automatically if you can't.
You have some statistics about behavior of the people or how that?
I can't remember on the top of my head, but most people, they never hit the limit. Yeah, so they have infinite amounts of storage space on their computers that they rarely use. So we use their storage.
And about DNS resolution or something like that, do you have about the peer-to-peer communication? Do you have anything about DNS? Nothing?
How do you mean? Sorry.
Because, I mean, you use a CDN, you said, right?
That's sort of the master storage. If it's not found on the local computer, and it's not found in the peers, and it's not found in our server's cache, then we pull it from S3, which is our master storage. But usually, as Martin mentioned, a file is read not maybe even once from this master storage, and if it's read once, then it's in the server's cache. So the CDN is not for making sure we deliver music really fast. It's basically another type of storage that we rely on for the origin of the file, sort of. But we might switch to another. So for instance, we launched in New Zealand and Australia, but we only have data centers in Europe and in US. So there's a big latency issue to Australia. But since our protocol, all the clients that stream music, when you log in, you open a TCP connection, and that one stays open. And that's you multiplex all the streaming music and the queries through that thing. So we gain a lot by not doing a DNS query and a TCP handshake and everything. We can just reuse the open connection. And most people in Australia, they haven't noticed that we are very slow yet. So it's working out great.
And thinking related on the DNS, we kind of nowadays tend to avoid it. Internally we have all our servers using this funky DNS magic with SRV records and TXT records. But for public-facing stuff, we're planning to phase out the DNS usage because it's kind of flaky. You get all bizarre ISPs doing all bizarre stuff with the DNS. You can't really do proper DNS queries on mobile. So yeah, we are aiming for, here's one address, go there and fetch like over HTTP where you connect next and forget the whole DNS from the thing, and then just multiplex everything to one pipe and be happy.
Yeah, so it's very robust system, but also you cannot rely on it.
Yeah, well, there are CDNs who do 2 DNS resolutions, just to one from the ESP and the second one from the user IP, just to be sure that you can localize the user and so on. So
we actually currently actually use the DNS also to pinpoint where you are. So we use GeoDNS.
Yeah,
and that's like a mess.
And I think one funny thing that we do with DNS is we send error messages back. Yeah, so if you have a problem using Spotify, we want to log that to make sure that we can fix the problem. But if that problem is a connection problem, you couldn't even reach our system, we would also like to have that information. But that's sort of impossible to send. But then the client actually is doing DNS queries after the fact when it's failed to find our system. And it's doing DNS queries sort of in sending information like to the service. I'm looking for, I couldn't connect to your system from this place. So then we have statistical information. We don't know which user or anything, but we can know if there's a problem in some part of the world, then we see an increase in DNS queries to our system. And then we can like, oh, this ISP seems to have a problem. Usually we find that problem earlier, but it's funny way to like get information from people who can't connect to your system. They're going through this DNS route instead.
So getting back to the P2P stuff, how do you stop people from taking advantage about the fact that now we know that you do that P2P stuff? Like, let's say I reverse engineer how your application works in some platform. I've already started looking into the macOS package, for example.
Yeah.
So how are you going to take, how do you deal with that part of security that it has nothing to do with my personal data, but it does have to do with data from companies that might not be happy that I take advantage of that?
One thing is that with the data we store in your cache, it's encrypted. So it's the encrypted docs, and we don't give you the key for decrypting unless you sync them being available offline.
And
so,
until the moment you start playing the music.
Yeah, then we fetch the key from the server. But we never, in normal use, we never store the key on your server. So we only store the cached files. And then for like reverse engineering and funky behavior, we have a lot of countermeasures, both in the client and especially in the backend, because you can't really trust the client. But they are really cool, and we do all kinds of nice stuff, but we can't really tell you because that would kind of moot the point of our countermeasures.
But it's like a stupid thing that we don't really want to have, but sort of like we need to do it. But the basic part is just having these encrypted blobs. If someone were to reuse our peer-to-peer network, that is great. They will distribute the files even more. But they can't really use it unless they're sort of using the other protocol. So I think it's possible to reverse engineer everything, and there has been like many, not many, but a few attempts, and we try to, yes, sort of not look into that direction until it becomes a problem. We don't want to anger anyone, basically.
That rules out Python as a client.
Yeah, unless you sort of build like the entire client in Python and just a wrapper around libSpotify. That could definitely possible, but the actual sort of protocol part wouldn't be visible, easy to read source code. So I think we actually do have internally the protocol implemented in Python for, yeah, we have a testing framework. So we have re-implemented protocol there.
Yeah, and just to add to that, well, even if you don't get Python directly in the official client, we mentioned libSpotify a few times, and just to be clear, libSpotify is out there. We're using it ourselves to build new clients, but if you don't want to wait for us, it's available for you as well.
Yeah.
So basically, you get a binary blob, which yes, you cannot hopefully reverse engineer, and hopefully you won't. But with that blob, you can build whatever you want around it, and put Spotify in whatever device or thing you feel like. And it's perfectly possible to use that binary blob to basically make a Python library to build clients in.
Yeah,
Just go ahead and do it.
It's very, very nasty looking, like not easy to understand bindings, but you have all the primitives that are used in a client. So just making Python bindings for libSpotify will look a bit strange, but eventually you can build something around it.
So what are your plans, or I guess maybe your stance on making plugins for, you mentioned the Sonos system earlier, and they have it, and my big complaint with Spotify right now is that it doesn't really work very well on Squeezebox. It's always been really painful. Do you guys plan to support that, or are you hoping that the community somehow magically supports it for you?
No, we're the Squeezebox as a Logitech product, right? Yeah, so they built their sort of libSpotify version into their speakers, like at the same time as Sonos, basically. And I think we should sort of do this through the official channels. Like if you have a problem with the Squeezebox, tell both Logitech. They're pretty good, like community forums, and tell the Spotify customer service is also like a community.spotify.com, and we'll sort of make sure it delivers what you sort of pay for. So you can do your own stuff, and the Squeezebox has a good sort of hacking community, but since we are dealing with a company that has made a sort of official Squeezebox client, we should continue to make sure it gets better. That's what we want to do. So bring us all the bug reports and we will fix them somehow. Oh, damn. Yep.
How many nodes are in your Hadoop cluster, and do you use any tools on top of that?
I think we have 50 nodes. We have a few different ones, depending on... we have one stable one that we never want to sort of touch, and it's the part that takes all the logs and build reports to the labels. It's very sensitive, making sure that always delivers on time. Then we have a few like experimental system where people like they take all the logs we have and try to find patterns in like, oh, people who have clicked this are likely to use this, and then just stuff, but just put stuff in that cluster. But I think that's the one that's the 50 nodes or something, and the other one is slightly smaller. And we're not using anything other than the normal Python streaming API for Hadoop. But at the time we started using it, the Last.fm actually had a framework for the streaming API, which they call Dumbo. And we started using that, and we found like a few flaws, so we started fixing it, and then we realized that it's a very, very tiny wrapper around the streaming API, so we just built our own, and we had to come up with a cool name for it, so we called it Rambo. It's like a bit more like than Dumbo. But then after a while, the Last.fm dudes, they're really good at doing stuff, so I think their framework is slightly better than ours now. Rambo is not so cool any longer. It's like from the 80s, yeah. But that's it.
Just another question on your API. How do you deal with updates to it? Also taking care of, an example, the Sonos devices you mentioned. Are all of them firmware upgradable? or if you update your API, you take care of supporting the old versions forever, almost.
Yeah.
Because I will not be happy to buy a set of speakers and not be able to use it from 2 years from now.
Excellent question. Yeah, that's one of the biggest problems with dealing with hardware, and that's why we love being a software company. And in the beginning, we only had the Windows client, but we sent automatic updates, and sometimes it could be like twice a week. Your client suddenly restarted, and it's like, there's no difference. Yeah, we just upgraded like a point version or something. And when we started dealing with those hardware companies, that became like, no, cannot do that. But all of the people that we are working with have sort of a firmware upgrade path. That still doesn't mean anything, because often the user has to interact personally. And if you are a user that buys sort of a set-top box for your TV, you don't even know what the firmware is. Like it's impossible. So that has been a new challenge for us to keep the sort of the protocol sort of the same, and we still want to make it better and improve it, but still keep the old stuff running. It's like the age-old struggle of how to do it. I guess we're trying as hard as anybody else. But in the beginning, we didn't. We didn't care. We could just like upgrade the protocol, send out new clients, kick everybody old out, and then iterate.
Yeah. We do a few things to mitigate the damage, the so-called damage from the old versions. From the client, we have been switching parts to be rendered with the embedded Chromium frame. So now we can actually, we see a bug in client, we just change the file on our web services, and it propagates to the client eventually. So we don't need to update our client anymore that much. And for the old devices and stuff like that, if we launch a new backend service, let's see, we launch like a new playlist backend now, totally rewritten in Java, blazingly fast, and Sonos doesn't speak that protocol. So in those cases, we make like a migration, like a little migration boxes in our backend that take in the old protocol and then convert it to the new protocol, and we just keep having this like own little playground for the old devices, and we hope to space out. We aim to space out the old stuff from the backend and then just convert the traffic to the new backend services.
That's actually a very good point. That's exactly how we intend to do it. We don't do it always. Sometimes we have one service speaking many protocols, but if we want to revamp and actually kick out all the legacy, we do that, and then we stick an adapter in between and hope to phase that out eventually. And that's actually a really good strategy to improve your software. Like kick out all the old stuff and put the old stuff in a tiny little thing that just adapts between versions.
Back to the original topic of this session, we use monitoring to monitor these adapters. So let's say there is a 1% of old speakers that are using the old API, so we sort of follow that and try to see when is the correct point in time where we can just cut it off and stuff.
Yeah.
So it's all thing of like good API design, that you have to support the old guys and the introduce new features. So yeah.
Okay.
Martelli had a really good talk last year at EuroPython about how to behave with API design and do versioning or not, and I sort of tend to agree with this. Don't try to support every version, but it's hard.
Thank you.
Now I have a Cassandra-related question. In general, there is a topic that people argue about, and it's major compaction in Cassandra. Do you perform it, and if yes, how often, and if it really makes a difference?
Yeah, I can start talking about how we use Cassandra. So in the beginning, we had this amazing, cool playlist system that was meant to make sure that you can edit your playlist when you're offline, and it would sync automatically, and that meant like confliction resolution. And by accident, we had built a distributed version control system, and it became a hassle to actually do the data storage for that system. And now, after like years, we have switched to a new one where Cassandra is the main storage. And in the beginning, we were like unsure, should we trust this? Should we invest time in it? And you really, really need lots and lots of time if you're going to go with Cassandra now. It's way better than it was like a year ago, but it's still not as easy as just apt-get install MySQL and ooh, it works and it's slightly faster and you can do it on many nodes. You need to really understand how it works. And compaction is probably the first thing that will hit you, and you will be very annoyed. And it's like this background process of the reason why Cassandra is so fast of writing is because it's a sort of append-only file format. So you just chunk every write operation and just put it on a file at the end. And it's like as fast as you can write to disk and not a lot of like random write operations. But then you might imagine like you have all this different data sort of appended at this end. So it doesn't really fit when you're going to read. So then you need to take these chunks and sort of like transform them into other sorted file chunks, which is easier to read from. And that process is called compaction, taking all those tiny sorted things and creating a bigger sorted blob, the SS table. And it's done as a background process. And whenever that kicks in automatically, you're supposed to not notice it, but usually you're relying on the performance of Cassandra being so blazingly fast that you will suffer when the compaction kicks in. I don't actually think we're doing manual compaction unless there is like an actual service issue somewhere and like, holy crap, we need to, okay, let's do compaction now because this is down anyway. But we try to make the background process work smoother and just making sure we have enough memory and don't overload the system and so on. And that's, now we come back to monitoring again. Like all machines have this limit of what they can achieve, but we rarely don't want to go above half of that, because when the turd hits the fan, then usually every machine will have like a huge spike in usage. And the biggest one is, this is a great question. I can talk about everything here. When user log in and they have this stable connection, OpenTCP connection, which is awesome for latency and everything, and they got disconnected for some reason, like, this has actually happened, like a boat in the sort of London harbor disconnected the cable and all UK traffic got rerouted to Stockholm or something. And the clients, they barely notice, they reconnect quickly, but that means everybody is logging in at the same time. So we call those logging storms. And so what do you do when you log in? You check, am I allowed to come here? Yes, you're allowed to come, your password is correct. And please, can I have my playlist? Yes, here they are. Or it hasn't changed since you last came. And that's like a big thing for the playlist system to just tell. So it needs to survive those moments, and it usually does. But whenever there's a compaction going on, there's a big queue of questions that cannot be answered, and then it's usually better to actually skip those. If you don't get an answer in 5 seconds, you wouldn't care anyway. So we have a lot of these logic in the system to just discard questions. And then we have lots of logic in the client to not care. So this leads to another topic, which is the Spotify client. We always want to be fast, and it should always work. And we changed those because they were so hard to achieve. So instead, we're doing things to make sure it feels fast. And the always working part, we changed that to pretend there's nothing wrong. And that's a great philosophy for actually making sure that you can build systems that do work. And that was the original goal of the playlist system, to make sure you can do edits offline and it wouldn't matter, and we can resolve any conflict. So yeah, this is great. It's like Git. You have a distributed version control system, but there's no conflicts because users can't change the same line. They can only append, move, and delete, and then we can solve all the conflicts for them. But we do have, indeed, lots of conflicts, especially when the playlist system is slower. Then it's not just people being offline, then it's like all the queries are coming in at different times. So please go use Cassandra and be wary of compaction and other scary stuff. Don't upgrade between 0.8 and 1.0, but there's no problem because 1.0 is already out, so you should start using that one. Yeah. One more.
I didn't want to take all the time, but if there are no other questions, I will ask. What do you use to monitor Cassandra? I guess it was Munin, but do you use a plugin like JMX to Munin or?
Yeah, I'm actually not sure about how the JVM sort of tools, how they are monitored, but we hired lots of guys from Oracle, and they were previously Appeal, who wrote the JRocket Java virtual machine. So they are really deep down into the JVM and doing any monitoring they can. But I'm personally, I don't know how to check Cassandra except for shouting on IRC and someone, oh crap, yes, we need to restart the thing. And we actually had the leap second bug. We thought we were safe. Turned out there was a problem in the JVM as well from Sun or Oracle. That's the only part where it hit us.
And small thing there, in general, for a lot of our services, we don't necessarily need to monitor a specific service or specific data for a service. Actually, usually what we do is monitor on a much higher level, like basically the health of the machine, use of memory, use of inodes and stuff like that. And we use that as an indicator of is something behaving as it should, and if not, then we investigate from there. And for a lot of our services, we don't even necessarily care about single machines. We care about clusters of machines, because a lot of our, I would say, of our services are robust, so we don't care if we lose 1, 2, 3, 4 machines. It's not a problem, the others will just take over. So we're actually mostly monitoring high-level trends. And so the graphing part is actually a lot about looking at graphs for loads over many machines or memory uses over many machines, and basically knowing, well, the curve should be something like this because it was like this yesterday and the day before, and if all of a sudden there's a spike or a fall, well, that's probably an indication that something has changed, so we go look at that.
And in cases of payments, we go even higher. So we monitor the business part of the whole payment system. So we don't really care about the load on the machines. Well, we do care, but not that much. What we care is how many transactions have been completed, how many transactions have errors, how many transactions toward this provider, how many transactions toward that bank, how they perform, and we monitor that. And that's usually, for us, much more important information. And I suggest, if you want to take something out of the monitoring part of our talk, to start building your monitoring system to monitor business decisions or business logic, and then go down. Because monitoring a machine, it's very easy. You just, like he said, apt-get, Munin, and that's it. But that doesn't give you anything else except, oh yeah, there's a load on 0.7 on that machine. So business logic first, and then down.
Okay. Unfortunately, I don't think we have time for another question, because it's taking really long to answer. So if everybody talks a bit, if it's taking 10 minutes.
And I really enjoyed all the questions, and thanks for
coming. Thank you, the Spotify team.
And if you have more questions, just go ask us. We're probably standing outside. For a while. And until